Alright, so this time we're solving problem 33 from chapter 5. And the problem says, you are lowering two boxes, one on top of the other, down a ramp by pulling on a rope parallel to the surface of the ramp. Both boxes move together at a constant speed of 15 centimeters per second. The coefficient of kinetic friction between the ramp and the lower box is 0.444, and the coefficient of static friction between the two boxes is 0.800. Part A, what forces do you need to exert to accomplish this? And then B, what are the magnitude and direction of the frictional force on the upper box? So to draw a picture to understand, we've got our ramp, we got boxes, the picture gives the mass, and you've got a person lowering them. I'm not great with drawing. That force should be parallel to the ramp. Drawing's not perfect. So we know that the mass of A, box A, is 48 kilograms. We know the mass of B is 32 kilograms from the picture. We know that this distance is 4.75 meters, and that distance is 2.5 meters. We know that the velocity is going to be 0.15 meters per second. Actually, no, sorry. 15 centimeters per second. And we know that mu of kinetic friction is 0.444, mu of static friction 0.800. So for part A, it wants to know what force do you need to exert to have this constant velocity. So we know that the sum of the forces is going to be equal to the mass times the acceleration. It's a constant velocity, so the acceleration is going to go to 0. We're just going to kind of work through it here. So we know that the forces is going to be equal to the force times the cosine of the angle minus the coefficient of kinetic friction times the mass times gravity. And that's going to be equal to mass times acceleration, which goes to 0. So we're not given an angle, but we can find the angle using geometry. So we know that the angle is going to be equal to the inverse tangent of the rise over the run. So 2.5 over 4.75. And so when we do that math, we get an angle. We get that theta is equal to 27.76 degrees. So we can then use this to find the force. So when we isolate for the force is going to be equal to times the mass times gravity divided by cosine of the angle. So we plug our values in, 0.8 times, and this mass is the mass of both blocks. So it's mass A plus mass B, that's going to be 80 kilograms times 9.8 divided by cosine of 27.76. And that gives us a force of 57.16 newtons for part A. Part B then wants to know what are the magnitude and direction of the frictional forces on box B. So we know that friction of static friction is going to be equal to the coefficient of static friction times the mass times gravity I used the wrong friction here. 0.444 should be that friction there to give you that answer. Sorry, my bad. So that is going to be equal to 0.8 times 32 times 9.8. And that gives you the frictional force, magnitude of the frictional force is 146 newtons. And when we're trying to figure out the direction, we know that the kinetic friction on box A is opposite of the force that's pushing them down the ramp. So it makes sense that the static friction on box B is going to be the same. So it's going to be this, that's going to be the magnitude of that force, and the direction is upwards along the ramp. And that is your answer to part B.